Dear students, in this video, I am going to discuss numerical problems appeared in the year June 2019. Okay, without wasting the time, let's get started. Let's have a look on the very first problem. In this problem, there is a square ABCD. Let me draw first a square ABCD. This is ABCD is a square. And the charges of 3 nanocoulomb and minus 5 nanocoulomb and plus 3 nanocoulomb are placed at ABC respectively. And we need to find out work done to move the charge of 12 microcoulomb. So charge has to be transferred. That let me take charge to be transferred. Transferred be Q, that is equals to 12 microcoulomb. From where to where we have to transfer? From D to the point of intersection of diagonals. So let me draw the diagonals. Let me take, this is the point of intersection of diagonals. Let me mark as O. So our aim is to find out work done to move this charge from D to the point of intersection of diagonals. So to find out the work done to move the charge from this point to this point, first we need to find out the electric potential at the point D as well as at point O due to these three charges. To find out electric potential at O as well as at D, we need to find out the distance of this point O as well as distance of this point D from all these three charges. So by using Pythagoras theorem, we can get AC as well as BD. So we know that AC equals to BD, that is length of the diagonals are equal. That is equals to, if the diagonals, that is equals to x root 2 meter. Here the value of x is 1 meter because the square of side 1 meter they said. So we can take, in place of x we can take 1. So if it becomes 1, then it will become root 2 meter. Now we need to calculate AO, BO, CO and DO. So you know that AO equals to BO equals to CO equals to and DO is equals to how much? That is half of the diagonal AC divided by 2. That is nothing but root 2 divided by 2. How much it is? Root 2 divided by 2 can be written as 1 by root 2 meter. So now we know that the electric potential is equals to, that is electric potential at O. Let me write electric potential at O is equals to, there are three charges, so we can use the superposition principle of electric potential. By the superposition principle of electric potential, we can write 1 by 4 pi epsilon naught, and here the charge placed at A divided by the distance of the point of consideration from A is AO plus QB divided by BO plus QC divided by CO. Now, on substituting the values, that is 1 by 4 pi epsilon naught value is 9 into 10 raised to 9, and QA equals to the charge placed at A is 3 nanocoulomb divided by AO value is 1 by root 2 plus QB equals to minus minus 5 into 10 raised to minus 9 divided by, that is 1 by root 2 because BO equals to 1 by root 2. Next plus QC equals to 3 into 10 raised to minus 9 divided by 1 by root 2. And here this plus and this will become minus. Let me write directly, this will become minus. Now let me take common things outside, that is 9 into 10 to the power of 9. And here 10 to the power of minus 9, 10 to the power of minus 9, 10 to the power of minus. Let me take that outside and divide by, here 1 by root 2 is common in all these three. So we can take 1 by root 2 outside. So we left with 3 minus 5 plus 3. So this 10 to the power of minus 9, 10 to the power plus 9 get cancels. And here we'll get, this is equals to, that is 3 plus 3, 6 minus 1, 1. So it will become 1 now. And then root 3, so this will become root 2 into 9 now. So root 2 value is 1.414. 1.414 into 9. So that is equals to 12.726 volt. This is V naught. In the same way, we need to find out VD also. So we know that VD equals to, that is VD. By using superposition principle, we can write VD. Let me write VD equals to 1 by 4 pi epsilon naught, and the charge placed at A divided by the distance of D from A is AD plus QB divided by BD plus QC divided by CD. Now substitute the values. That is VD equals to 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9, and QA value is 3 into 10 raised to minus 9, and AD equals to 1 meter plus QB equals to minus 5. Let me write directly minus 5 into 10 raised to minus 9 divided by BD equals to, we know that BD equals to root 2 plus QC, the charge placed at C is 3 into 10 raised to minus 9 divided by 1, that is CD equals to 1 meter. So now on simplifying this, that is VD equals to 9 into 10 raised to 9, and here 10 raised to minus 9 can be taken outside, and here we will get 3 minus 5 by root 2 plus 3. This is nothing but this and this get cancels, that 10 to the power plus 9 and 10 to the power minus 9, and it will become 9 into 3 plus 3, 6 into 5 by 6 minus 5 by root 2. So we know that 6 minus 5 by root 2, that is 9 into 6 minus 5 by root 2 value is 3.536, and this is equals to 9 into 2.464. On simplifying, we will get VD equals to 9 into 2.464 gives us 22.176 volt. So this is VD. We got electric potential at D as well as at O. Now we need to find out work done. So work done, that is to move the charge 12 microcoulomb, that is work done equals to here VD minus VO into charge to be transferred. Now substituting the values, that is VD equals to how much here, 22.176 minus VO equals to 12.726 into charge to be transferred is 12 microcoulomb. So on simplifying this, we will get 22.176 minus 12.726, 9.45 into 12 into 10 to the power minus 6. This is equals to 113.4 into 10 raised to minus 6 joule. So let me express my final answer to the one decimal place. So we get W equals to 1.134 into 10 to the power minus 4 joule. This is work done to move the charge 12 microcoulomb from D to the point of intersection of diagonals. Okay, let's go to the next question. See, in this problem, we need to find out the equivalent resistance as well as total current in the network. So first, let me draw the given network. So here we have resistance, that is 4 ohm resistance we have, and one more 4 ohm resistance we have connected in parallel. Next, in series, we connected 1 ohm resistance, is a 4 ohm, and this one is also 4 ohm. And here we connected 12 ohm resistance as well as 6 ohm. This is the given network. That is 6 ohm, and this combination is connected to the source of EMF, that is 16 volt, and the internal resistance 1 ohm. So what is our aim? Our aim is to find out the net or equivalent resistance. So let me simplify this network. We know that whenever the two resistors are connected in parallel, by using the formula Rp is equals to R1 R2 divided by R1 plus R2, we can get the equivalent resistance. See here, two resistors are connected in parallel. So by using this 2, that is, let me consider 4 as R1, this 4 as R2. So 4 into 4 divided by 4 plus 4. How much it will become? That is equals to, that is 4 into 4, 16 divided by 8, 2 ohm. So this is nothing but the equivalent resistance of these two resistors equals to 2 ohm. Next here we have connected 1 ohm. So 1 ohm resistance, and equivalent resistance of these two resistors equals to, that is by using the same formula, that is Rp equals to, we can use now Rp is equals to R1 R2. So here let me consider 12 as R1 and 6 as R2. 12 plus 6, this is equals to 72 divided by 18. 72 divided by 18 is 4. So this will become 4 ohm, and this is connected to the external source of EMF 16 volt and 1 ohm resistance. So now you know that these three resistors are connected in series. So if they are connected in series, we can take R1 plus R2 plus R3 formula. So here R1, let me consider 2 as R1 and 1 as R2 and 4 as, so this will become 7 ohm. So this will become now. So the equivalent resistance is 7 ohm, which is connected to the external source of EMF 16 volt and 1 ohm resistance. So we got now, this is equivalent resistance. So equivalent resistance of this network is equals to 7 ohm. This is the first one. Next we need to find out the current in the circuit, current in the network. So this is equals, let me find out this current in the circuit. So we know that the current in the circuit is equals to, that is current in the circuit is equals to E divided by external resistance, that is equivalent resistance, plus internal resistance. So E equals to, here the EMF of the source is 16 volt divided by equivalent resistance is 7 ohm plus internal resistance is 1. So this will become 16 divided by 8. So current in the network is 2 ampere. Okay, let's go to the next question. So in this problem, we need to find out impedance of the circuit as well as the phase difference between the voltage source and the current. The phase difference between the voltage source and the current is called phase angle. That means we need to find out phase angle as well as impedance. First, let me find out impedance by using this given data. So let me take the impedance is equals to, that is impedance is equals to, we know that impedance equals to R square plus XL minus C whole square. Okay, now we know that resistance, but we don't know XL as well as XC. Here XL means what? XL means the inductive reactance and XC means capacitive reactance. That we need to find out the impedance. So let me find out first XL. So we know that XL is equals to 2 pi FL. So on substituting the values, 2 into pi value is 3.142 and F is 50 and L is equals to 25.48 millihenry, 10 to the power minus 3. Now 10 to the power minus 3. Okay. Now on simplifying this, we get 2 into 50 is 100, and here let me make one decimal place, it will become 2.548. So it will become 100. Now we can write 3.142 into 2.548 into how much? 2 into 50, 100. Here we have taken 10, so it will become 10 to the power 3, and here already we have 10 to the power minus 3. 10 to the power plus 3, 10 to the power minus 3. So get cancelled. So we will get here 3.142 into 2.548. So I'm simplifying this, we get XL. That is XL equals to 8.0058. So this is nearly equals to, that is 8 ohm. XL is 8 ohm. Now let me find out XC. So we know that XC is equals to, so XC is equals to 1 divided by 2 pi FC. So I'm substituting the values, that is 1 divided by 2 into 3.142 into frequency, in the frequency of NEC is 50 and capacitance is 796 10 to the power minus 6 micro. So on simplifying this, we get XC equals to 1 divided by, so that is 2 into 50, 100 and let me write here 3.142, and let me express to the one decimal place. This is 7.96, and here we got 15 to 100, 100 into here 100, so 10 to the power of 4, and here we have already 10 to the power of minus 6. So on simplifying this, we will get this is equals to, that is 1 divided by 3.142 into 7.96 is 25.01 into 10 to the power of 4 into 10 to the power of minus 6 is 10 to the power of minus 2. This will become 100 divided by 25.01. So this is nearly equals to 100 divided by 25.01 is nearly equals to 4 ohm. So let's see XC. XC equals to 4 ohm. So after getting XC and XL, so we can find out now Z. So we know that Z is equals to square root of R square. R means here 3 square plus XL. XL is 8 minus 4 whole square. This is equals to, and we can write now, this can be written as so 9 plus 8 minus 4 square 16. So this is equals to square root of 25, and this can be written as Z equals to, so 5 ohm. This is the impedance in the circuit. Okay, now the next question is the phase angle, that is phase difference between the voltage and the current is called as phase angle. That we need to find out that equals to, that is we know that the power factor, that is cos psi equals to R by Z. So here the psi is the phase angle, so psi equals to, so that is, let me substitute here, cos psi is equals to, here R equals to how much? R equals to 3, and Z we got 5, 3 by 5. So if cos psi equals to 3 by 5, then phi equals to 53 degree. So this is what we can write, because we know that from the right angle triangle, so we know that if suppose if I consider the right angle triangle, so let me consider this is 53 degree and this is 37 degree. From the triplets we know that this is 3 and this is 4 and 5. Now we know that here if we apply this one, that is cos 53 degree, then the cos 53 is equals to how much? This is 3 by 5. So cos 53 equals to 3 by 5. So here we got here cos psi equals to 3 by 5. So we can write here psi equals to 53 degree. In this way we can get the answer. Okay, let me move to the next question. In this problem, height of the image is 3 centimeter. Then object distance is 14 centimeter. That is, it should be taken as negative, because according to Cartesian sign conventions, the object distance should be negative for that reason. And it is a concave lens. For that reason, the focal length should be taken as negative. The focal length of the concave lens is negative. So we have to consider the minus 21 centimeter. What is our aim? Our aim is to find out the position of the image, nature of the image, as well as the size of the image. So let me find out first position. To find out position, we know that the thin lens formula, that is 1 by V minus 1 by U is equals to 1 by F. This is thin lens formula. So make V as a subject formula because V is the position of the image. So let me make V as a subject formula. 1 by V equals to 1 by F plus 1 by U. So on simplifying this, we will get UF. Let me take LCM as UF, and then here we will get U plus F. Now what we want? We want V. So make V as a subject formula. So V equals to UF divided by U plus F. And substituting the values, that is U equals to minus 14 and focal length is minus 21 divided by U is minus 14 plus focal length is minus, that is, let me take minus 21. So on simplifying this, we get, that is, V equals to 14 into 21, 294 divided by minus into minus, it is plus, and here minus 14 minus 21 becomes minus 35, and 294 divided by minus 35, this is equals to minus 8.4 centimeter. That is V equals to minus 8.4 centimeter. By this we can write that the image is formed on the same side of the lens at a distance of 8.4 centimeter. So we can write here image is formed on the same side of lens, same side of the lens at a distance of 8.4 centimeter. 8.4 centimeter. Okay. Now we need to find out the nature. So we know that in the case of concave lens, the nature of the image is virtual and erect. So nature of the image is virtual and erect. Next, let me find out the size of the image. We know that from the magnification formula, the magnification is nothing but V by U, the size of the image to the size of the object, or else image distance divided by object distance. This can be written as height of the image to the height of the object. This is the magnification formula. That is magnification equals to V by U equals to HI by H naught. This can be written. Now we make the height of the image as subject formula. So we will get height of the image equals to V by U into H naught. And substituting the values, this is equals to V equals to how much here we got? 8.4, that is minus 8.4, and dV equals to minus 14, and into, that is height of the object is 3 centimeter. I'm simplifying this, we get height of the image is equals to 1.8 centimeter. So observe this height of the image and height of the object. So by clearly it shows that the height of the image is less than the height of the object. So the image is diminished. Image is diminished. So diminished image is okay. Okay. Let me go to the next question. In this problem, we need to find out the binding energy of the alpha particle in mega electron volt by using the given data. So the given element is alpha particle, that is nothing but helium particle. So mass number is 4 and atomic number is 2. So we need to find out binding energy. Binding energy is nothing but, that is binding energy is nothing but mass defect times 931.5 mega electron volt. Binding energy is the energy which is responsible to hold the nucleons together in the nucleus. That is equals to delta M into 931.5 mega electron volt. So first we need to find out delta M to find out binding energy. So we know that the delta M, that is nothing but mass defect. Mass defect is the difference between the mass of the constituent of the nucleus and actual mass of the nucleus. That can be written as, that is ZMP plus A minus Z, that is number of neutrons to mass of the neutron minus actual mass of the nucleus. This is the formula for mass defect. That is difference between the mass of the constituent of the nucleus and actual mass of the nucleus. So now on substituting the values, that is Z equals to here 2 and mass of the proton is 1.007825 plus A minus Z. A minus Z is 2. Mass of the neutron is 1.008662 minus actual mass of the nucleus is 4.00260. So I'm simplifying this. 2 into 1.007825 is 2.01565 plus 2 into 1.008662, 2.017324 minus 4.00260. On simplifying this, we get 4.032 974 minus 4.00260, and this is equals to, that is mass defect equals to 0.030734. This is a mass defect. Now after getting mass defect, we need to find out binding energy. So now binding energy is equals to mass defect times the 931.5 megaelectron. That is mass defect is 0.030734 into 931.5 mega electron volt. I'm simplifying this. We get 28.29 mega electron volt. This is the binding energy of the alpha particle in mega electron volt. Okay. Thank you. Thanks for watching.